Hello, this is day 5 of chapter 12, sequences and series, and this is about geometric series, which is basically just the sum of n terms, so how many ever terms we're adding up of a geometric sequence. Alright, so here are some formulas we've already done. Arithmetic sequences formula, and arithmetic series formula, which is the sum formulas, and we've done geometric sequence formula, which was day 4. So today it's the series, geometric series formula, which is this one right here, and later on we'll get to the sum of a geometric series formula if we're adding an infinite number of terms, which is kind of weird to think about. So here are some examples. Find the sum of the first 8 terms in a geometric series. You should maybe say the sum of the first 8 terms in a geometric sequence, because it's kind of already stating that if we're finding the sum, it is a series. But regardless, that means that we were finding S sub 8. And based on what the formula says, we need a sub 1, which is right there, and then 1 minus r to the n. And on the bottom, it's just r. All right, and the exponent belongs to the r, so on top. So this is going to be 8 for whatever r is. So we need to figure out r. Now, this is written as a series because if it were just a sequence, it would just have commas. It'd be 14, and then the next term, negative 70, and then the next term, 350. And to figure out r, so that's the only difference here. That's the way it's written. To figure out r, we need to take a term and divide it by its previous. So maybe 350, its previous is negative 70. Or we could have done negative 70 divided by 14. Either way, this will give us the same r value, and it's a negative 5. So if we have a negative 5 for r, we kind of see that since that, like, we got to simplify some things, but since the 8 is connected to the negative 5, we can't just subtract 1 minus negative 5 first. We have to do that exponent. On the bottom, however, we could simplify that. 1 minus a negative 5 is plus 5, basically. 1 plus 5 is 6. So we need to know what this is. Negative 5 to the 8th power. And be sure to put parentheses there. Negative 5 to the 8th power. It is a positive number because we have an even exponent. It's going to multiply this negative 5 times itself an even number of times. Negative times negative is positive. So we'd end up with a positive number. That's why it's important to put the parentheses around there, because if you put a negative 5 to the 8th, a calculator may think that we mean a negative outcome, and we don't. We just want a negative 5 raised to the 8th. 390,625. So 14. 1 minus 390,625. Okay. And on the bottom, we have 6. And then this is, we could put all of this into a calculator at this point. Just 1 minus that is going to be a negative number, 14 divided by 6. $14. 1 minus 5. Now divided by 6. And I get negative 911,465. Oop. 456. And so that's our number. And you may wonder, like, well, if we're adding up a positive number and then a negative number, it's going to be a negative. Like as we go on, this would be just these two would make a negative number. But then if we add 350 to it, then these 3 would give a positive number. Then these 4 would give a negative number because we're adding a bigger negative number. And so it's okay that we got a negative number when we added a sum. If we added up another term, we'd probably end up with a positive number. And it's just because the terms are alternating signs. All right. Then, well, before I go on, number 1 is just a basic find the sum of the terms problem. So we would do exactly like that, fill in what we know. This next problem is saying find the first term. Okay, so we have to know everything else. We know the sum of the first 5 terms is negative 2882 over 81, and our r is 5/3. So fill in what we know. If we were doing, s sub 5, here's the formula. And fill in what we know. Negative 2882 over 81 equals a sub 1, don't know it. 1 minus 5/3, and that is raised to the 5th power. Why 5th? Because that's what n is, the amount of terms. All right. So we need to get a sub 1 by itself. We should figure out what all this other stuff is. But ultimately, this a sub 1 is just being multiplied by essentially a fraction of this, like this fraction. You could think of it that way. And so a sub 1 being multiplied by that, we could find out what that is and divide it to both sides. So this is, we want to know 1 minus parentheses 5/3, parentheses raised to the, move the cursor over a little bit, raised to the, we get some number there. I want to divide that right away, just because I'm going to have some decimals. I need it to be accurate, so I'm going to want to let the calculator do this all at once, so we don't have any like errors from rounding, because it may not end up perfectly, and we got to have exact numbers. Otherwise, if any of these numbers aren't exact, then it may end up causing a rounding error, essentially. All right, 1 minus. All right, so we end up with that right there. So we just compare this to what we have. Notice that I typed all this stuff in, and that number then that I get from Desmos is just 17.79, whatever. That's times a sub 1. So let's take it a step farther and say if I wanted to get a sub 1 by itself, 17 point blah 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 blah. We have to divide both sides by 17, and then a whole bunch of stuff. So divided by 17. I put those dots there just indicating I'm not just taking some decimal. I'm taking the exact number that the calculator is giving me. So I get 17.79, whatever. And if I want to kind of do this whole problem all at once, I could say that it's a negative 2882. So I'm going to the beginning of this problem, divided by 81. And then I am dividing that whole piece. And it doesn't want me to do it. So I will copy it and insert it down there. Oh, that looks really ugly. But I just showed you how we broke it down into little pieces. And I didn't want to do it one by one and then write down every single answer, because I may have approximation errors. Just I might get an approximate number instead of an exact number, and the calculator knows that if we do it all at once, I want the I'm only using exact numbers that it could give me. So this whole Decker problem stacked all together looks really crazy. But if you did these separate divisions and then chopped off some of the decimals just to round up or to try and be, I don't know, lazy or time efficient, we would have errors. So I wanted to do it all at once if possible, but I still broke it down step by step. So we end up with a sub 1 being -2. We certainly could try to maintain, just turn them all into decimals and write as many decimal places as we can. And as long as the decimals didn't get chopped off by the calculator initially, it could work out. Ooh, this is an interesting problem. So which is a better deal? Let's say you get $1 million today. Okay, well now you got $1 million. That's excellent. Or you could, I could give you 1 penny today, 2 for tomorrow, 4 for the next day, and so forth for like 30 days. What this means is, so today would be 1 penny, 1 cent. And then tomorrow you're going to get 2 cents. And the next day you're going to get 4 cents. So I wrote these as in terms of dollars. So it's like $0.04 or, you know, that's how much change. And then for a month and for 30 days, that's basically the same thing as making a sequence where you start with 0.01 and then you get 0.02, then you get 0.04. You can see that it's doubling each time. And then I want to add them all up just to see at the end of 30 days how much did I get. So this would technically be a series adding up each of these numbers, and I'm not sure, whatever. This would be whatever a sub 30 is. It's going to be some larger number because this was a sub 1 and for 30 days. But I want to add them up. So this is s sub 30 essentially. And we would know that the first term is 0.01, and we just need to know the rest of it for the formula. And it's a series again because I want to know the total amount that I would be given at the end of 30 days, if it's better than $1 million or not. And we're starting at a penny, so you know, maybe not, I don't know. 1 minus r. R is 2 because we are doubling. And then raised to the n power. Okay, and if it's not clear that it was doubling, just we need to keep in mind that what is 1 penny today, 2 tomorrow, and 4 the next? That's pretty explanatory that r would have to be 2. All right, so this we can just straight up put all in the calculator if we want. It's all on one side. There's not as much solving. So this says, let's put parentheses just to keep the top. Maybe we don't need to. 0.01 times 1 minus 2, but 2 is raised to the 30th power. And close those parentheses, divided by 1 minus 2. Let's verify I typed it incorrectly. 0.01 parentheses 1 minus 2 to the 30th over 1 minus 2. Looks good, but look at that number. That's a huge number. So that is pretty crazy. We could also just, if you were really curious, so it's 10, 7, 3, 7, 4, 18. 23 cents. That's a lot of money compared to $1 million. So really, this is kind of a lesson in delayed gratification, where if you can wait 30 days instead of getting $1 million up front, obviously if there were some guarantees involved, we'd end up with 10 times the amount, over 10 times the amount. And this should make a little bit of sense if we just let's just figure out what the 30th term is. The 30th term, a sub 30, if we started at 0.01, if this were just a sequence, we just want to know what the 30th amount would be. This would be 2 times n minus 1 would be 30 minus 1. So just that 30th term, the last amount I'd be given on the 30th day, 0.01 times 2 raised to the 30 minus 1 is 29. Just that last amount is already $5 million. So we would think that this would be the better deal, obviously. If by definition of a better deal, it means more money. So again, this is a series, a geometric series lesson, and it's just about knowing this formula and write it down at the beginning, obviously, and plug in what you got. Knowing the difference that if we are adding all these terms together, it's a series, and if we're just looking for a particular term in the sequence, then it's a sequence formula. All right, I hope this helps, and good luck.